Hi, my name is Austin Stanton, and in this webinar, I'm going to be telling you how you can use LabVIEW to control your instrument. But first, I want to talk about why you'd want to control your instrument using LabVIEW. And the first big reason is automation. Automating your solution can not only save you time, but it can help you avoid many of the common obstacles associated with repetitive measurements, user error, storing your data, reporting, and then mixed signals and instrument integration, and many other different errors. While I say this, obviously not every single measurement is better off automated. There's some times where manual measurements make sense, and it would be a waste of time to go through that. I have some resources that I'll talk a little bit more on later on about, but that will help you make that decision of whether you should automate your instrument. But once you've made that decision and you know that automating your instrument is the right choice, the first thing you need to think about is how you're going to actually communicate between your development machine and your instrument. So the first thing you're going to want to do is look at your instrument and determine which interfaces it's actually able to communicate over. For example, this Keithley DMM is able to communicate over Ethernet and USB, which is perfect since I'm able to connect that to my computer very easily. Other older instruments actually use GPIB and serial pretty consistently, which obviously my laptop and most modern desktops don't have GPIB or serial ports. So in that situation, you're going to need to use an adapter to convert from GPIB and serial over to whatever interfaces your laptop or desktop can use. We actually provide those at NI. So we have GPIB to USB converters, along with GPIB to Ethernet converters, and we even have a PCI and PCIe card that you can put into your desktop computer for GPIB and serial as well. So you having an older instrument that uses GPIB or serial shouldn't stop you from moving forward with trying to control your instrument. So after you've figured out how you're going to actually connect your development computer to your instrument and you're able to start the communication, the next thing you're going to need to think about is software. So there are two components to the software side. There is the driver side, which is going to handle all of the low-level communication. That's going to help you communicate over USB, Ethernet, GPIB, serial, all those communication all those communication interfaces. It'll kind of abstract that away from you so that you can simply send a command and it will send it through that interface. On the other side of that, you have your programming languages and programming environments. Things like Python and .NET are very popular for this, with Python especially being popular because obviously it's free, it's very easy to use, but it's easy to use until it's not. And that's one of the big things that we've heard is that people will get most of the way through a Python application, and then they'll maybe hit an obstacle or wall that they're not able to get through, and then have difficulties finding support for that. And that's really where LabVIEW comes in, is that LabVIEW is designed for automating instruments. It has the most comprehensive and easy to use instrument control solution available. And because it's developed by and maintained by NI, if you run into any issues, you can simply call up our technical support team, and we can make sure that we get you figured out, get you over that line with your application. So then let's talk a little more about why you'd want to use LabVIEW. And the first reason is that it's just really easy to use. We have over 7,000 instrument drivers that are completely ready to run and include documentation and examples. These instrument drivers basically completely eliminate the need for you to go and learn all of the low-level instrument commands. That way you can spend less time in your instrument's manual, learning all the commands, and spend more time actually working on your application. The next reason is all of the built-in advanced analysis that you can do. LabVIEW has everything you need to acquire, analyze, and visualize your data, along with filters, signal processing, probabilities, mathematics, and everything else that you would need in this type of a test and measurement application. Finally, LabVIEW makes it extremely easy to create custom user interfaces that are perfectly fit for your particular application. So rather than continuing to go on and on about LabVIEW and how easy it is, I'm going to go ahead and show you. Let me just quickly change my setup, and then we can go on with the demo. All right, so now I'm set up with my Tektronix oscilloscope connected to my Keysight waveform generator. They're both connected to my laptop over USB, and then I've actually got the output of the waveform generator from the Keysight waveform generator to the first channel of the Tektronix oscilloscope. So the first thing you want to do anytime you're using hardware with NI software is open MAX, which is Measurement and Automation Explorer. And really quickly, I just want to show you, if you open up and expand the software tab, you'll be able to see all the different software that you have downloaded on your computer. The big thing that I want to point out here is that I have LabVIEW 2021, and that I have NIVISA 2021 installed as well. So NIVISA is the driver I mentioned earlier. It's the driver that's actually going to be handling all of the low-level communication interfacing over USB, Ethernet, GPIB, serial, making it so that all you're having to do is send a command, and it's handling actually sending that over those particular protocols. So you don't have to worry about which protocol. It's basically all the same to you because of NIVISA. So next place you want to go is to the Devices and Interfaces section to make sure that you see your devices. And as you can see, I do see my Tektronix oscilloscope, and then right below it, I do see my Keysight waveform generator, and then I'm able to see the VISA resource name for each as well, which is going to be important in a second. So the next thing you want to do, and the first thing that you should probably do yourself right now, if you have a particular box that you're thinking of controlling, is going to NIIDNet. So that is our instrument driver network. So this is where this is like the repository for all of those 7,000 instrument drivers that I had mentioned before. You are able to see all the popular drivers here. And then we also have different guides to help you work through, get it from getting started to learning more about instrument drivers to actually step-by-step installing and running examples. All of that can be found in these links here. But for now, I'm just going to go ahead and search my particular oscilloscope, which you can see it pops up as a Tektronix 3012. I search that, and you can see that there is a driver here. So if you're thinking about automating one of your instruments at home, make sure that you come here first, see if there is a driver available. If there is, that'll save you a bunch of time. If you don't find the driver on IDNet, that does not necessarily mean that one doesn't exist. I highly recommend reaching out to the manufacturer. Sometimes that they have LabVIEW drivers available that they just haven't been certified by NI to be on the instrument driver network. So here you can see that there are two different types. One is LabVIEW specific, the other is LabVIEW, LabVIEW CVI, and our other text-based programming. This one is the one that I need since I'm using USB. I don't need all the other interfaces for GPIB or serial. So I'm just going to go ahead and go to the driver page for this top one. And then I'm going to pick this LabVIEW 2021 version and download that. So it's going to download as a zip file onto my computer. I'm just going to save it in my download section. And then I'm going to open up, and I'm going to just extract this. And then the place you want to extract it is you want to go to C, and then you want to go to Program Files, x86, and then you want to navigate to National Instruments, and then you want to navigate to the LabVIEW version you're using, in this case LabVIEW 2021, and then to instrument.lib. So then once you're here, you can just click Select Folder, and it will extract it into that folder, and that's the correct location. And that'll make sure that all the examples and sub-VIs all go into the places you'd want them. So from here, generally what I'll do is within this folder, I'll just open up the particular folder and I'll open up the project here. So the project is going to have all the examples along with the sub-VIs and everything else, just all in one place. You can kind of get a feel for what's all included in the driver. Also includes the documentation, everything else. But I'll show you how you can separately find everything here in a minute. So like I said, you can see all the different examples in this example folder here. And then if you open up the library here, you can basically see all of the sub-VIs, which are basically just little functions or commands. And basically, if you were to open up the documentation, the communication documentation for this instrument, all of the commands that you would find in there, you'll find similar commands here. It's basically just wrapping those commands within a sub-VI. So then rather than having to know exactly what command you're sending and where you're sending it to, you're just basically putting down the sub-VI, plugging in the constants or whatever you need to input into it, and it will work just as well. So it saves you a lot of time there. Let's go ahead and open this just first continuous waveform example. And what we'll do is we'll select the VISA resource name. So from here, we can see that the Tektronix scope is the USB, and then it's the 699 for the VISA resource name. So I can come back here and select that, and I can go ahead and run it. So just like you'd expect, since I'm not outputting anything from my waveform generator at the moment, it's very close to 0 with just a little bit of noise. Let me go ahead and stop this, and let's take a look at the block diagram. So for the block diagram, this is very standard. Basically, we're opening or initializing, we're configuring, we're doing something within a while loop, and in this case, you're reading a waveform, and then once you stop, you're closing the reference to the scope. So let's really quickly just dive into the initialize here, just to basically show you that deep down it's all just VISA commands. So we're just sending particular commands, commands that you would have found within the documentation for the box, like this star IDN query, just querying the instrument, getting its initial state, initializing, sending like the amount of bits you'd expect to read back, all that type of stuff. All of that you're no longer having to do. You don't have to worry about any of this anymore because it's already been built in with this sub-VI structure. And the great thing with the fact that it's using VISA is that you don't have to worry about whether you're communicating over Ethernet or USB. If I set all of this up and built the whole program using USB and then decided, oh, I want Ethernet because I need a longer connection type, you could simply just switch and then input the changed VISA resource name, because that'll change if you connect over Ethernet, and then everything will run the exact same way because VISA is just handling that lower level connection. You're just telling it what you want it to do. It's handling how it's actually being sent. So now to demonstrate an actual application, I also installed previously the instrument driver for this Tektronix waveform generator, and I have this example here. So I can assume that it's going to just be the other VISA resource here, since obviously the 6099 is for the Tektronix scope. I can select that, and then I'm just going to run the scope again, and I'm going to run the output of the waveform generator. And so we'll be able to see that as I click change, you'll be able to see a slight change here, and then as I increase the frequency, you'll be able to see more of a change. I can then switch to, let's switch to square, the other way, yep, switching to square. I can adjust the amplitude up and down, and you're really quickly able to see the change here, basically only limited by by the communication speed of USB. Of course, it is all software time, so it's not going to be completely deterministic, but you can see it's very responsive when we actually go and are changing this. So then I go ahead and close this all out. And yeah, that's a demonstration of what you can do and just basically how easy it is to start taking measurements when the LabVIEW instrument drivers have already been created. So it's just a very, very simple experience. You could then just build on one of these examples, add anything else you needed to, and you're not having to worry about all those lower level commands for initializing and configuring anything else like that. So let's switch now back to my presentation. All right, so now that I've kind of shown you how easy it actually is to do this, let's summarize and go back through the checklist of what you would actually need to do. So first off, like I mentioned before, you actually need to determine that automation is going to be right for your project. Not every application needs to be automated. There's a lot of situations where manual will work just fine. So first determine that. Then next you're going to have to determine how you're able to communicate with your instrument. Is it going to be over Ethernet, USB, because it's a newer instrument? Or if it's an older instrument, you're most likely going to be thinking about GPIB or serial, which then when you come to think about how you're going to be communicating with your development machine, you're going to have to start thinking about adapters, thinking about how am I going to convert from the GPIB interface on my instrument to the USB or Ethernet interface on my development machine. So once you get that all figured out and you're able to communicate, then that's when you start thinking about software. I obviously highly recommend using LabVIEW. You can download LabVIEW for a free trial, and I guarantee you within that trial you'll be able to get this all figured out. Once you have LabVIEW, you can download NIVISA, which again is going to be that driver that handles all the low-level interfacing between all the low-level communication between the different interfaces. And then finally, you'll want to install the particular instrument driver. And I would actually say that if you are considering doing this for a particular instrument, just go onto IDNet right now, check to see if we have an instrument driver for it. If we do, that's obviously going to speed up the process a huge amount. So overall, I'd say if you went and downloaded LabVIEW right now, you could probably be communicating with your instrument and setting up an application within an hour from this, obviously depending on your download speeds, but I'm confident to say that it would not take you very long to actually start taking measurements and proving out the concept of this actually working. Really very low risk considering that we have a free trial available. And if you want to take things a step further, you can also use GWeb to basically deploy your user or your front panel user interface to the cloud, meaning that you can actually view that front panel interface from anywhere, from any browser, whether it's your phone or your tablet or your PC at home. So that can be beneficial for a lot of different applications. And if that is something that is appealing to you, definitely check out the test workflow bundle. You can purchase both LabVIEW and GWeb through this bundle, and it basically has, along with a lot of our other premier softwares, that are going to give you everything you need to be able to automate your instruments, analyze your data, and then perform tests. So definitely check out that bundle, and there's a link to that in the resource list as well, as you'll see right here. So here are all the different resources that I have in the resource list. I have a resource to help you determine whether automation is actually right for you. Highly recommend checking that out if you're on the line of whether it would be right for your application. Have another one that goes through all the different considerations for choosing the right hardware bus, things like bandwidth and latency that you might need to think about just to make sure that the particular interface is going to meet your needs. Then I have a link to to IDNet, the instrument driver network. Definitely check that out as soon as possible to make sure that your instrument driver is there. And then a NI test workflow bundle page so you can learn more about the bundle and GWeb and what you can do kind of with all the different NI softwares together. And then finally a getting started with instrument instrument control and LabVIEW guide, which goes much more in depth into all these different steps than I was able to in this webinar. So if you're interested in getting started, definitely check that out. And yeah, that should be extremely helpful. But yeah, thank you so much for watching my webinar. And if you have any questions, please throw those in the chat and we'll do our very best to answer them. Thanks a lot.